So this problem here amounts to what is a linear inequality problem. So we're going to try to find the two ends of this spectrum here, where this company charges a per kilowatt hour rate, and then they also charge a fixed charge every month of $7.08. And this is a pretty common scenario if you've ever looked at a power bill or gas bill or things like that. They typically charge a fixed fee, so even if you don't even use any gas, like in the summertime, but the company still charges, say, $25 a month or something like that. And then, of course, in the winter months, when you start to use more gas, they start to charge you more. It's a pretty common scenario, this is. So we have the fixed amount, which is $7.08, and that does not change every month or every bill cycle. But what does change is we have that we pay 9.853 cents. Now, first off, we need to make sure, since this is in dollars over here, we need to put this in dollars. So 9 cents, remember, is 0.09853 is how we'll write that as in terms of dollars. So we're going to say 0.09853, and then we pay. So if you have 1 kilowatt hour, then you pay 9 cents. If you have 2 kilowatt hours, and you pay twice that much. So the reason I say all that is because that is the expression for the bill. So if you don't have any kilowatt hours, you still pay $7. If you have 10 kilowatt hours, you pay 10 times however many per kilowatt hour the charge is, and then add the $7.08 charge. So that's a pretty standard mathematical representation we would use here. And so we know that this is the bill amount, right? This tells us what the bill amount would be based on some amount of kilowatt hours. And they've told us that the bill has a low of 57.21 and a high of 218.73. So this amount right here, we would say, well, it's greater than 57.21, right? And it's less than 218.73. And I guess technically here we should use equals to, because it says it can be equal to those numbers. That's not really important, because we'll get the same results for these two answers regardless. And so now that we have that, we just do algebra to these parts here. And so we solve compound inequality like this the same way we would solve any inequality or equality even, is we do it, but in this case we have to do it on the left hand side and the right hand side. So that's eliminated, and we subtract here and we get $50.13. Subtract 708 over here and we get 211.65. And so we bring down the rest of our expression. And now we divide both sides by this 0.09853. And so this middle term cancels and we have x. And now we just need to pull out our calculators here and find these numbers. So the left-hand side, divided that and I get 508.779. Now notice it says here in the blue instructions, it tells us how to enter that number. It wants 2 decimal places. And so we get 508.78. Since we go to the third decimal place, it's greater than a 5, which means we round this up to from 7 to an 8. And now we'll do the division on the right-hand side. And so likewise, we'll round to 2 decimal places. So that 6 right there says to bump that up to an 8. So 2148.08. And so those are the two numbers that you'll put in the box. So the minimum kilowatt hours is the 508.78, and the maximum is 2148.08.